So we gotta figure out these points again. So let's see. Just make a list over to the side. So what's happening here? The clock has an 8-inch long moving hand. Center is 120 inches from the floor. At time 0 minutes, so one point is going to be 0, comma. It's directly up. So how high would that be? It's at its highest point, so that would be 128. The clock is not working properly, and the minute hand is moving twice as fast as it should. Thus, the next time it points directly up is 30. So I'll have the point 30, comma 128. Is that okay? Remember this? We did this before. So halfway in between, so 15. Where will the hand be? Halfway in between.
120.
It'll be straight down.
Or not 120.
Won't it be straight down?
112.
So it would be 112. And then, I didn't leave myself enough room here, but halfway in between those, so 7.5 and 22.5, where will I be? This is when the hand is straight up. This is when the hand is straight down. So halfway in between would be when it is straight sideways. So that would be 120. And then, everybody okay? And then we put those on here, and we have to pay attention. We have no idea what the X coordinates are, we don't know what the Y coordinates are either in terms of the grid here. But we do know that's the highest one. So I'm gonna maybe put this one as 0, 128. And then what would P be then? If that's 0, 128, P would be 30, 128. And then the low one, halfway in between here, is 15, 112. And then these are the midway ones, so 7.5, 120. Okay, I know that's old news. It doesn't hurt us to do it again. Are we okay? So let's talk about this now in terms of it being a sinusoidal thing. Could this be a sine curve? Yeah. Could it be a cosine curve? Yeah. Because what's the difference between them? It's all about where you start looking. If you start looking, if you've got some crazy thing and you start looking right here, then that is a sine. But if you start looking right here, then that would be a cosine. It's the same curve. So that could be either one. Does it have a period? What's its period? Period is 30. So what's its frequency? 1 over 30. Does it have amplitude? Well, yeah, if it's sinusoidal, it has amplitude. What's its amplitude? Half the distance from the top to the bottom, that would be 8. How high is this hill? That's 8. Why is the amplitude 8? What in the problem makes the amplitude 8? The thing that's going around, right? The thing that's making it periodic, that hand, that minute hand. And what's its midline? What would be the equation of this dashed line right here? Y equals 120. Yep, that's its midline. Now let's answer, oh wait, did I already answer them all? Oh, let's answer the questions, and then we're going to see if we can actually write an equation. I think that might be a stretch for us, but I want to try it, because I think it's exciting. So we did period, frequency, amplitude, midnight. Everybody okay with that? All right. Find two intervals for which the graph is both decreasing and concave up. So we're going to have intervals now. Intervals. And we're going to be decreasing and concave up. So can you give me one? Okay, Cole?
7.5 to 15.
I'll let you. So from 7.5 to 15. So that would be one. When we did these before, we talked about in terms of the letters. So from G to J, right? Is there another interval that is both decreasing and concave up? Declan? 37.5 to 45? Wait a minute. That's not even on my picture. What's Declan thinking about?
And 30.
He added 30. And why did he add 30? Because 30 is the period, and whatever happens here happens 30 later, and 30 after that, and 30 after that. Very, very good. Is that okay with everybody? Okay. Now, we gotta go back in time a little bit and think about how we modify our equations. So, how do we do a vertical translation? Would you agree that if this were written, if this thing was on a regular grid, a regular piece of graph paper, this thing has been lifted up? How is that reflected in an equation? Where do I put a number that accomplishes a vertical translation? At the end. So whatever's going on, and this probably is going to be some kind of, let's just do a sine equation. It's going to be some kind of, or maybe we'll do a cosine equation. So we're going to have some kind of cosine equation, but at the end of it is going to have a plus 120. Does that make sense to everybody? We have lifted it up 120. Now I'm going to write this as a cosine equation because right here I'm at 0. So I'm going to write an equation for this right here. So it's been lifted up 120. Now, what is the amplitude of a regular cosine? Your basic cosine, we did this yesterday. We took it right off the unit circle. So what was its amplitude? 1. Why is the amplitude 1? Because it came off of the unit circle, right? What is the amplitude of this picture? 8. How do we do what we call a vertical dilation? How do we accomplish that in the equation? Where do we see a vertical dilation? What? Out in front. So right out here from the 8. We have multiplied the curve by 8. That multiplies the y values. Right? Now, this particular cosine curve, luckily for us, is starting right at 0. Isn't that where a normal cosine starts? Doesn't a normal cosine start at 0? So what have we not done? We have not done a horizontal translation. So where do those show up in the equation? Horizontal shifts. X plus or something. So whenever my X is here, I'm gonna go ahead and put a plus 0, but I wouldn't have to do that because I haven't moved it. But isn't that where the sideways move comes in? Yep. Right, now here comes the hard one. This number right here, whatever it is going to affect, it's a horizontal dilation, right, Alex?
Would it be 120 if you're in degrees, multiply x by 120? If you're in degrees, or,
So,
right?
we're going to do everything in radians. So what do you wanna multiply?
Because I did 360 over 30, so it would be 2 pi over 30. So it would be pi over 15.
Remember, this number right here divides your horizontal. That's a divider. What is the normal period of a cosine? The one we drew yesterday. What was the period? Start to finish was 2 pi. This one is not 2 pi. This one is 30. So we have changed the period. And that happens through dividing by something. Alright? So I don't know what that is that I'm going to put in there. But 2 pi divided by it gives me my new period, which in this case is 30. 2 pi is your standard period. If you put a 2 here, it would make it 1 pi. 2 pi divided by 2. This number, your horizontal translation, is a divider. So if we take our normal period and divide it by this number, we're going to get our new period. So 2 pi divided by 30 is that number. Would you agree with that? So this number is pi over 15. And there, you guys, is the equation of that curve. That is great. You did great with that. So now we're going to go one step beyond this. Someone asked me last period, Warren Robertson said, how do you know if you got sine or cosine? You have both, right? It just depends where you start looking. If I start looking at 0, this is a cosine. But what if I started looking right here? What if that's where I decided to start looking? What if I looked at this portion of the graph? Then that would be a sine. Now here's the good news. If it's a sine equation, nothing's changing in terms of amplitude. Isn't the amplitude still going to be 8? What? It is negative. Very good. Well, now the amplitude's not negative, but that multiplier is negative because this sign is upside down of a regular one. The period isn't changing, so isn't this coefficient still going to be pi over 15? Because it's still 30 units start to finish. It's still lifted up 120. None of that has changed. The only thing that's changed is what? Where we start. So instead of starting at 0, now we're starting at 7.5. So this will be x minus 7.5.
So if could you start at 30 and how to do cosine?
Start up here. You can start anywhere you want, and that if you started there, if you start at the top or the bottom, it's a cosine. If you start anywhere on the midline, it's a sine. So what Declan just said is, how many answers are there in this problem? How many different equations could we write? A lot. This is a teacher's nightmare because grading it is so hard. But the good news is, all of the equations will have these numbers in common. Now that might be positive or negative. Here it was negative, but what if I started here? If I started here, it would be positive.
Can you explain why it's negative?
Because it's upside down. Signs go up and then down. This one's upside down. Right? That is awesome. You guys are amazing. Okay. That was above and beyond. Let's turn to page 4. Look at to check your understanding. explain why the range of the sine and cosine is negative 1 to 1. Where did it come
The
from?
radius.
The unit circle, right? Isn't that where it came from? And the farthest up and down, left and right a point can go is 1 unit, right, in the unit circle. How many full cycles of sine theta can be graphed between negative 2 pi and 4 pi? Cole says 3. I see lots of 3s out there. Why? Because the period is 2 pi, and you've got 6 pi units here, so that's gonna be 3 periods. Good. Ooh, here's a blast from the past. Is cosine even, odd, neither? How do you know? Anybody remember anything about even and odd?
Is even when it equals itself, or like when.
When you
f
plug
of
it,
x
okay.
equals f of
Alright, let's
x.
get our calculators out. And it doesn't matter if you're in degrees or radians, just type cosine something, and then type cosine negative that thing. So like cosine 2, cosine negative 2. I'm gonna try it with a couple other numbers. Cosine 93, cosine negative 93. What happens when you put a negative in? They're the same. They're the same. Now, I know we only did 2 examples, but what you just told me was that cosine x turned out to be the same as cosine negative x. Right? You all tried different numbers probably, and that works for everyone, right? So is it even? Yeah? Because like Alex said, that's the definition of even. Now, can somebody tell me graphically how we know it's even? Alex?
Is it because it repeats at starting at the 0?
Well, Avery,
Because it starts at zeros, and then it like reflects onto.
on the y-axis. So your cosine curve that we draw is over here, but remember it goes in both directions. So the definition of an even function graphically is it has symmetry about the y-axis. Does cosine have symmetry about the y-axis? Yes, cosine is an even function. Cosine is an even function. Good, that's some good review. All right, what about sine? Is sine even, odd, or neither? What do you think about sine?
Odd.
Odd, why do you think that?
Because it starts at the origin.
I know how to do it with decimals.
So it is symmetric about the origin. If you look at your sine curve, doesn't it have symmetry about the origin? Try this. Type sine 5 and sine negative 5. They're not the same. Isn't one negative? That's what it means to be odd, right? So sine negative x equals negative sine x, the opposite of sine x. We have symmetry about the origin. So, beautiful. Cosine is even, sine is odd.
Oh, hell yeah. I don't know.
What?
Oh, the answer to 3, was it even?
It is even.
Symmetric
About the y-axis. Yep. Yep. All right, number 5. Which of these is true about cosine? We ready? Number 1. F of x equals f of negative x. We're talking about cosine now. True, that's even. That's what it means to be even. It means the negative doesn't matter. So that's true. The graph has a y-intercept at 1. The regular cosine. Does it have a y-intercept at 1? Yes, guys, that's where it starts, doesn't it? 1? You guys paying attention? Got it? The graph is concave down over its entire domain. Yeah. That's just weird, right? Is part of it concave down?
No.
Yeah. The x-axis represents the cosine ratio. That's kind of a tricky question because we know cosine is the x-coordinate, right? But when you graph a cosine, you graph a cosine. Let's just do the regular cosine. What are these labels? This is the x-axis. And what do these represent? Aren't these your angles? So the x-axis doesn't represent the cosine values, it represents the angles. The y-axis represents the cosine values. At 0, the cosine is 1. At pi over 2, the cosine is 0. At pi, it's negative 1, and so on. So the x-axis is the angles. The y-axis is the actual cosine values. That's a tricky question. F of 146 pi is 1. I hear some truths. Because the period is 2 pi, and wouldn't 146 pi just be 73 periods? Yeah. F is undefined for negative values. Is your cosine ever undefined? No. What does your cosine look like forever and ever and ever and ever? It's just up and down and up and down and up and down. It is never undefined. What can be undefined? Not cosine. Tangent can be undefined. A tangent graph is full of asymptotes because it can be undefined. Sines and cosines are never undefined. That's why they're our favorites. You can always, always find sines and cosines. All right, next page. We've already talked about this because you guys wrote your equation already because you're super smart. So on page 5, let's look down at example 1. So we're on page 5. We're looking down at example 1. And you are going to tell me, figure out right now, values of A, B, and D in the equation. Now, A has to do with the amplitude. B will have to do with the period or the horizontal dilation. And D will be your vertical translation, right? So go ahead and figure this out. See if you can figure out what your equation is going to be for the picture that's drawn there. This is hard, guys. This is trickier. This is only your second time you've ever done this, and I'm asking you to do it by yourself. But I think you can figure it out. Talk to each other. A and D are the easy ones usually. That B is a little bit tricky.
I just did it.
Anybody fill in any of them yet? Any of these blanks? Ben?
A is 6.
6?
2, B, plus 3.
All right, let's take a look at what Ben did and see if that makes sense. Anybody else get these numbers? Some of you did? Good. So, remember, this guy out here is your height multiplier, your vertical multiplier. That's called your vertical dilation. The normal height of your hills is 1. Well, how high is this hill right here, you guys? 6? So it's been multiplied by 6. The amplitude is 6. Normally, your curve is going to oscillate across the x-axis. Obviously, this one has been moved up because it's oscillating on the line y equals 3, that's its midline. So that's plus 3 on the end, that's called your vertical translation. And then what's that 2 doing in there? That 2 impacts this. What is the normal period of a sine curve? Just the flat out normal period of a sine curve is 2 pi. The period of the picture he drew is pi. So what's happened? We have divided it by 2. And remember, that's what this number does. This number right here divides the period. So the standard period is 2 pi. We've divided it by 2, so our new period is pi. Okay? Now, I'd like you to write same picture, but I'd like you to write a cosine equation.
How come in the last time we wrote the sine equation, the A number was negative?
Because the sign was upside down? Is this sign upside down? Or cosine?
No.
So this is sine. Is this sign upside down? No. So remember what a negative out front does is turn your picture over. If you valley first, you're upside down in a sine curve, if you do the valley first. This I'm doing hill. This is normal, so that's going to be a positive coefficient. Now, I'm going to write a cosine. So that means I have to look at a different portion of the picture. So could I look at this portion of the picture for my cosine? Yep, there are other pieces I could look at, but that would work. That doesn't alter the amplitude, it doesn't alter the period, and it doesn't alter the midline. It's the same picture. What it does alter is, now I have to start at, oh, what would that be? Pi over 4? That okay with everybody? Pi over 4? Which means this would be x minus pi. Alex?
Why is the 2 not inside the parentheses?
It can be. In this case, it would make 0 difference. But if I'm gonna call that my horizontal translation, then the 2 has to be outside. Here, it would make no difference at all. But if you wanna know what your horizontal translation of the phase shift is, the 2 has to be factored out. So I always just build my equation that way. If you put it in here, that would be pi over 2.
Would you count it wrong if you like distributed it?
Yeah, as long as you had the right, right numbers, yeah. Alright, just for fun, one more. Write me a negative sine equation. Same picture, but I want a negative sine equation. So what would that look like if I want a negative sine? Cool.
-6 sine 2 then x minus 3 pi over 4.
Now be careful. 3 pi over 4 would be right here, right?
Yeah.
And if I started there, that wouldn't be a negative sign, that would be a negative cosine. Remember, sines start on the midline. Cosines start at the top of the bottom. So if I want a negative sign, can I just start right here? Would that work for me? So x minus pi over 2. And that would have to be a negative. All right, you guys that have these negative questions, you see the difference? The original one we wrote, and this one, see how they're upside down of each other? So that's why we needed a negative. Okay? Awesome.
So if you asked for the sine equation, then you didn't like ask for positive or negative, those are both right?
Yeah.
Okay.
And infinite or many others you could come up with. Because you could start right here and have a sine equation. You can start right here and have a sine
So I
equation.
had that for the original sine.
You did?
Yeah, so I was lost a
And,
little bit.
okay, and that would be okay, except in the original equation, there was no C, there was none of this.
Okay, yeah.
So if you're not, if he gave you the format you need, it was A sine bx plus d or something like that. So your equation had to look like that to meet his expectations.
Okay, yeah, I get
But
it.
this would be the same. This would be okay. All right, let's try it for number 2. Write an expression for f of theta. This time, you're not told whether it's a sine or a cosine. So just for fun, let's do both. Let's write 2 equations, for example, 2. 1 cosine and 1 sine. So something cosine, something x, something, and something sine. So in reality, there are 4 numbers you could put into your equation. A vertical multiplier, a horizontal divider, and then your 2 translations, left and right, up and down.
No, it is. It's like almost
Anybody have it yet? Still working on it? Have you figured out your amplitude? What's your amplitude? 3. So I'm just gonna put 3s out here. I may need to make one of those negative depending, but for now I'm just gonna put 3 out there. How about your midline? Have you figured out what your midline is? 3s, these are gonna be plus 3s. How about your period? Have you figured out what your period is? Pi, which means there must be a 2 here dividing the 2 pi to get pi. Everybody with me so far? If it's a cosine curve, where do you want to start it if it's a cosine curve? Pi over 4. So x minus pi over 4. What if it's a sine curve? right, started at the beginning, and you don't need a 0 in there, I'm putting it because I had a blank there. Is that all right? If we chose, for whatever reason, to start the picture at pi over 2, then it would be a negative sine curve. All right. All right, number 3. What are the values of the period and amplitude? All right, so look at the picture G, example 3. What is our period? Pi. All right, so it's either A or B then. What is our amplitude? 2. So I guess it's A. Example 4. This is another one where he gives us the maximum and the minimum. So we have a maximum at pi over 2, 6. And the next minimum is pi negative 4. Which of the following could be an expression for the function? Well, let's check the amplitude first. It looks like we're going from 6 to negative 4. That would be our range. So the amplitude has to be half that, so that would be 5. So it's either C or D. What is the period of this curve? We're going to continue it on. What would the period be? From top to bottom is half a pi. So won't the whole period be pi? Which means your coefficient on x must be 2. So the answer is D. Is that what you said? Example 5, multiple choice, here we go.
How does it not have a horizontal if it's peak? Is it shouldn't it have
Should it have the phase shift?
because like I did the sign, I got that.
I'm not sure. These are only on. All right, number 5. Which of the following could be the graph? So what are you thinking about as you look at the pictures? Did you take out A right away?
Yeah.
Because A went up 1 and I need to go down 1, so I'm going to take out A right away. My period has to be pi. Oh. Is C the only option then? Why does my period have to be pi? Because the coefficient on x is 2, and 2 pi divided by 2 is pi. Very good. All right, phase shift, you've already been talking about that. Here we go, number 6. Which of the following could be an expression for that function? Okay, now he's got cosines and sines all mixed in. All right, so let's see. Okay, so they all have an amplitude of 3, a shift of 1, and a period of 2 pi. All right. So I gotta find more. But why isn't it A? I'm gonna tell you it's not A. Why isn't it A? Because the thing is upside down, right? And 3 is positive, so it can't be A. Now the next one, x minus pi. Now I want you to think about this for a minute. This is your period stuff. X minus pi, well, where does that start? That starts up at the top of the hill, doesn't it?
Yeah.
Can it have a negative coefficient? No. X plus pi over 2, well imagine backing that up. If you backed it up to negative pi over 2, wouldn't that sine curve be upside down? So it's gotta be D. Gotta be D. Alright, let's get 7 done. Which of the following could be an expression for A? Let's participate this time. Let's see if we can figure it out. Some are sines, some are cosines. Notice they're all positive. Alright, so we gotta look at positive pictures. Okay, somebody throw something out. Let's see if you're right.
C.
A, C? A and C are almost the same, except A is a cosine and C is a sine. So at pi over 4, am I at the top of the hill or on the midline? So if I'm starting at pi over 4, it's gotta be a sine, right? And if I start at pi over 4, it's a positive sign. I think C is right. Is that what you guys said? Sines start on the midline, cosines start at the top or the bottom. All right, one more, and then I'll shut up and you can do whatever homework. All right, here we go. This is like the one we did first. Only he gives you the points. So the points are 216, 511, 86, 1416. Those are our points. And he wants you to write a sine equation. Now, what can we tell about the amplitude? We're going from 6 to 16, so the amplitude will be 5. We may end up making that negative in a minute, we'll just have to wait and see. How about our midline? What's our midline? No, our midline isn't 6. Our midline is 11, right?
Oh.
How about our period? What's our period? Our period is from 2 to 14, so our period's 12. So 2 pi divided by what is going to give me 12? Remember, that's how you find your period. 2 pi divided by that number. So what's that number gonna be? 2 pi equals 12n. It looks like that number is gonna be pi over 6.
Can you just put 2 pi over the period?
I mean, that's what ends up happening.
Oh, yeah.
Now, this has to be a sine curve, so you're not going to start here, right? Could you figure out this point and start back here if you wanted to? What would that point be? -1, 11? Could we do that if we wanted to? And then what would this equation be? What would have to go here? X plus 1? What if you didn't want to do that extra work? What if you just wanted to start right here? Then you'd have to have a negative out here, and that would be x minus 5. And both those would be perfectly, and others, you could start here if you wanted to. Anywhere on the midline would give you a sine curve. You guys have made tremendous progress today. Good job. 3436, oh no, 3435 will be due on Friday. And we'll finish 36 tomorrow.
Oh.